Hello everyone. Today we are going to learn the shortcut method to calculate limits. Here I have written some of the standard limits. The first one is limit x tends to 0, sin x by x is 1. Same way, sin inverse x by x is 1, tan x by x is 1, tan inverse x by x is 1. From here we can get some of the approximation values by shifting the x to right side. Sin x approximately equals to x. Same way we can deduce here tan x by x is 1, so shifting x to right side we get tan x approximately equals to x. Same way the other two expression. Here I have written the second standard limit. Limit x tends to 0, e power x minus 1 by x is 1. It can be proved easily by Arithmetic rule. So I get here, bring x to right side, e power x minus 1 is approximately x. Same way, log 1 plus x by x, limit x tends to 0 is 1, bring x to right side, we get log of 1 plus x approximately equals to x when x tends to 0. Last limit x tends to 0, a power x minus 1 by x is equals to log a, shift x to right side, a power x minus 1 is equals to x log a. So these are our approximation values. When x tends to 0, this is a condition required. Sin x is approximately equal to x, tan x, x, tan inverse x is equal to x, sin inverse x equals to x, e power x minus 1 equals to x, log of 1 plus x is equals to x, and a power x minus 1 equals to x log a. Now, important note, apply only for product type problem. Do not apply if the expressions are separated by plus or minus sign. Now let us see some of the problems of JEE Mains in advance which can be solved using this approximation. Question number 1. Limit x tends to 0, e power x minus 1 whole square by sine of x by k log 1 plus x by 4 equals 12. This question appeared in JEE Mains 2015. Okay, you have to find now value of k. Now here we can note that each of the term is of product type. Here multiplication, here square term is again multiplication. Now here x is tending to 0, so e power x minus 1 is approximately equals to x. Same way, sin x by k is approximately equals to x by k, and log of 1 plus x by 4 is approximately equals to x by 4. Because this x is tending to 0, each of this is tending to 0. So I got the problem now transforms to e power x minus 1 is x, so here get x square. Denominator sin x by k is equals to x by k, and the log term is equals to x by 4. X square get cancelled, you get 4k, and that is equals to 12 as per the problem. So we get k value equals to 3. 12 by 4, 3, that's option C. Question number 2. Again this problem appeared in JEE Mains 2015. Limit x tends to 0 and the expression is given. We can see that here product type, denominator also product type, so I can use my approximation. Now here first we'll use the standard trigonometric formula, that is 1 minus cos 2x is equals to 2 sine square x. Substitute here, limit x tends to 0, instead of this 2 sine square x into 3 plus cos x divided by x times. Now tan 4x is approximately equal to 4x, because when x tends to 0, 4x also tends to 0. So using my approximation I can use this. Substitute here 4x. Now sin x is also approximately equals to x. Substitute here. So limit x tends to 0, we get 2 into x square Sin x is x, so sin square will be x square. 3 plus cos x by 4x square. So the x square get cancelled. We get 2 times 3 plus, put x tends to 0, cos 0 is 1 by 4. 3 plus 1, that is 4, get cancelled, answer is 2. That is option C. Question number 3. Question number 3, it has appeared in J Advanced 2016. It is integer answer type, that is answer is one of the integer from 0 to 9. Again here, limit x and 0. Here you can see product type. Here addition subtraction, so do not apply approximation here, because we saw that approximation can be applied only for product type. You can see that numerator's product types apply approximation here. So we can use sin beta x is approximately equals to beta x, because x is tending to 0, sin beta x will be approximately equals to beta x. So the limit transforms to limit x tends to 0, x square is x square itself, and this is beta x, sin beta x equals beta x, alpha x minus sin x. So we can write limit x tends to 0, beta x cube divided by alpha x minus sin x. Substitute 0, so here numerator is becoming 0, denominator also 0, so 0 by 0 form, we can use hospital rule. So differentiate the numerator part, we get limit x and 0, 3 beta x square divided by alpha minus cos x. Now you can see when we substitute limit here, x tends to 0, numerator is becoming 0, therefore denominator must be 0, then only the limit can be finite quantity. If denominator is not 0, then the whole limit value will take 0 value, because numerator is tending to 0. But they already mentioned that limit is 1, therefore alpha minus cos, instead of x you put 0, it should be 0. So we get alpha minus 1 is 0, alpha equals to 1. Okay. Now proceed further. So this is 0 by 0 form. So we have to again apply hospital rule. We get limit x tends to 0, 6 beta x divided by alpha is a constant, differentiation is 0, minus cos x, that is sin x. Now we know x by sin x, that's 1. When x tends to 0, we get 6 beta, and this limit is equal to 6 beta, and they have given the value, that is 1. So we get beta equals to 1 by 6. Therefore 6 times alpha plus beta is equals to 6 times 1 plus 1 by 6, that is 6 times 7 by 6. We get answer as 7.